Welcome to the latest edition of our Expert Insight video series. I am Woodrow Bellamy III, Senior Editor with SAE Media Group. Heat treating has always played a significant role in the aerospace industry. It will continue to play a role well into the future, with new innovations being adopted across the industry, such as additive manufacturing, meeting the need for lighter components with higher temperature resistance, and bringing new or previously hard-to-machine metals into the aerospace material mix. Nitrex has been providing heat treatment services to the aerospace industry for several decades. To provide some insights on some of the current industry trends that are driving demand for innovation within heat treatment services, Mark Hemseth, president of Nitrex Turnkey Services, is a guest on this edition of our Expert Insight series. Welcome to the series, Mark.
Well, thank you, Woodrow. Thank you for having me.
So, Mark, as an introduction to this topic, what are some of the main factors that aerospace OEMs must consider when selecting a specific type of heat treatment as part of their manufacturing process for newly designed products or solutions?
Well, Woodrow, aerospace is all about weight reduction, right? They must select materials that are both light and strong and will provide decades of service. Weight reduction and strength do not always go together, so heat treatments can assure that the parts all have the same properties if properly heat processed after making the parts. So once the engineer specifies the parts and materials, then we come in with our vacuum furnaces or our coating VPA furnace and or our gas nitriding systems. To be honest, not that many parts are nitrided in the aerospace sector because steel is the material that's nitrided and steel is heavy. However, there are various stainless blades, components, and airfoils that are vacuum processed to stress relieve, anneal, etc. in the heat treatment world. An example of a part where expensive nickel cobalt alloys and other super alloys are used is in the hot end of the engine, the turbine, so to speak. Here, survival under hot oxidizing environments is the key. So that they use what is called single crystal super alloys, and our coating furnaces provide a very high temperature oxidation resistance known as vapor phase aluminizing. This heat treatment is done to protect the oxidizing effects of the hot gases as it hits the turbine blades. After the parts get our furnace treatment, they are often top coated with an even higher temperature coating, which is typically a ceramic-like coating. On the cold end of the turbine, they're trying to reduce weight. So you'll see new types of blades on the front engines of the newer ones, and they are using what they call composites, and they're bonded to titanium. I toured such a plant for a commercial airliner cold engine blades manufacturing facility, and although we don't have furnaces there, they don't use them. It's amazing how many processes make up one blade just to save the weight and have the strength. And that's basically how we use heat treatment as it relates to Nitrex.
And as a follow-up to that, what are some of the emerging materials or alloys that are being adopted by aerospace manufacturers that are driving changes in heat treatment services and methods?
I think many alloys have been created and used. As I mentioned, now they're perfecting what they call single crystal super alloys, and this is in the engine, the turbine engine. And they're also adding the composites, which I mentioned, all over the aircraft to make them more fuel efficient and lighter. The higher temperatures on the turbine add efficiency. The lighter weights with the composites and titanium add efficiency. We only deal with the steels and super alloys here at Nitrex with our vacuum furnaces like nickel and nickel cobalt and titanium. We typically do not offer systems for aluminum alloys. This is a little bit specialized heat treatment world. I think we will see more advances in composites. Again, not an area that we address, but you'll see it a lot in the structures and in different parts where they can reduce weight. You'll also see very high temperature super alloys, and you'll see alloys used to limit corrosion, especially hot corrosion. I should say that in almost all cases, most of aerospace industry likes the vacuum furnace over, let's say, what they call an atmosphere furnace, because a good vacuum atmosphere is devoid of both oxygen and water vapor contaminants. The extra cost of a quality vacuum furnace is preferred in the aerospace world.
As more aerospace OEMs are increasingly adopting additive manufacturing, what type of solutions are you providing to enhance the additive process and achieve high levels of quality assurance in finished parts?
Well, additive manufacturing has really grown in the last years. It makes a lot of sense in aerospace. Even though we build a lot of aircraft, a few hundred planes a year is more the norm, maybe 1,000, which is not at all like automotive where we're talking millions. So the amount of parts that they build are much fewer in quantity, but the quality is way, way higher. In the parts world and casting world, as I said, this is not a lot of parts. So it's a little bit harder to make them in this fashion. However, in the 3D printing and additive manufacturing world, parts are made one at a time. This higher cost of the single pieces lends itself to additive manufacturing for aerospace products. However, you can do more sophisticated parts with the 3D printing, and a lot of these will need some sort of heat processing. For instance, debinding of the binders that are used in jet printing, sintering after the binders are taken out to make the part more whole. There's a process, which is a temperature process that we don't use, called HIP, hot isostatic pressing, which is also getting a lot of use. And of course, there's things like stress relief that's needed with furnaces. For this reason, because of additive manufacturing and because it's a smaller volume and lot world, we're really pushing our smaller vacuum furnaces. We make vacuum furnaces for as small as a cubic foot or two of space. This is a lot different than some of the furnaces that we make, which may be 8 foot by 8 foot in space. This type of smaller furnace might mesh well with the printer, which is taking time to build parts. Binder jet printing is not a fast process, but a very exacting process. Our furnaces, as I mentioned, can also be used to remove the so-called binder, which is left over in the part from the binder jet printing process. Removal of binders is actually a low temperature furnace process, and it works better actually under vacuum pressure. So our furnaces are ideally suited for the 3D printing additive manufacturing world.
And speaking of additive manufacturing, what role does advanced simulation software or other digital tools provide in optimizing heat treatment for additively manufactured aerospace parts and components?
Thank you, Woodrow. The world today is about digital tools, right? Understanding your process, documenting what you did, and keeping it forever. Nitrex has a digital platform called Cumulus. We can connect all of your furnaces and log all of the data and allow you to manipulate it and confirm your quality. But our platform is so much more. We can analyze the health of the furnace. We can let you know about scheduled maintenance. We can find issues of a furnace not performing as it was before it causes quality issues. We can document all this for your quality system and department, which is so critical in aerospace. We can provide all the maintenance records and instructions of how to service your furnace. We can calculate and run the cost, and we can even calculate your carbon footprint. All of these things are very important in today's world of digital. We can manage your quality audit needs, which is also important. Today, the software makes the aerospace furnace user's life much easier. If you are doing surface treatments like carburizing or nitriding, we even incorporate some of our simulation tools. Of course, aerospace likes to have very strict procedures, and we live within that rigor.
And when you look out over the next 5 or 10 years or so, Mark, what are some of the future trends you see emerging within the heat treatment process for aerospace manufacturing, and how are you addressing those trends?
Well, as I mentioned, things are getting smaller, 3D printing, etc. We think the equipment for the heat treatment market is desired to be smaller, so it can be nearer to the part processing area. So for instance, if you've got a 3D printing area, you might have a small furnace right there to deal with those single parts that come out. Vacuum furnaces are not just the norm, but are almost solely prescribed for certain alloys like titanium, nickel alloys, stainless alloys, and corrosion resistant alloys. And that's a trend. So vacuum is becoming bigger and bigger. In the old days, there were more what we called atmosphere furnaces. You might have a nitrogen atmosphere, but it was never good enough. And this is why vacuum furnaces are much more desired for cleanliness and to make sure you get repeatable results. The science of protecting the alloys from hot oxidation is always advancing in the coatings field, and that's where our vapor phase aluminide furnaces come into play on the hot engine parts. As we mentioned before, digital tools are a must. That's a trend that has been going on obviously for decades, but the digital tools are much better today than they were even 10 or 20 years ago. Planes need to be more efficient and lighter. They want to use less carbon and less fuel. And of course, we don't want to jeopardize safety when we make the planes lighter. In the space field, speaking of rockets, I think they're getting bigger as there are so many payloads to carry up into the stratosphere, like satellites. So a lot of things are changing, a lot of trends, and we at Nitrex think that we're trying to keep up with these trends, and we have a lot to offer.
Well, thanks, Mark, for providing some of those insights on current and future industry trends. That brings us to the end of this edition of Expert Insight. Thanks, Mark, again for joining us. And if you'd like to learn more information about the heat treatment services provided by Nitrex, go to nitrex.com, and we'll see you on the next edition of our Expert Insight series.